Assalamualaikum and a very good morning to all panels. So today I would like to present about my final year project 1. First of all, I would like to introduce myself. So my name is Muhammad Hafizuddin bin RAZELI. So my metric number is B051820034. So my title is Development of a Drone that is capable of gentle landing, which is supervised by Prof. Dr. Ahmad Yusairi bin Bani Hashim. Okay, so in this presentation, there are 3 chapters, which is Introduction, Literature Review, and Methodology. First of all, I would like to tell you about introduction of my project. So, Unmanned Aerial Vehicle, which is UAV, popularly known as drones, are autonomously or remotely operated aircraft, which can fly without onboard human pilot while being operated from the ground. Currently, drones are for multiple purposes such as for entertainment as a toy, for civilian application, for example, monitoring soil erosion and wildlife, remote sensing, surveying and photogrammetry, smart agriculture, disaster surveying and management, forestry, energy harvesting and housing renovation, scientific applications, and military application surveillance and attacking the enemy. So, as the evolution of drone technology continues, its battery capacity and the range of the flight increase, therefore also increasing the range and scope of tasks drones can be assigned to perform. Statistics of accidents during the operation of an unmanned aerial vehicle, which is UAV, exhibits a significantly higher accident rate compared to pilot aircraft. This poses several limitations on the possible adoption of unmanned systems, particularly in the civilian airspace. So next, problem statement. So we have all seen a quadcopter in the sky flying so majestically in one location until it drops like a rock. Unlike fixed wing aircraft, quadcopters lose lift when the battery is depleted or it is operating outside of prescribed GPS boundaries, or the unit is in free fall, or even when the craft is upset beyond its ability to recover. So, due to these problems, drone can be unmanageable, fall down, and land on hard surface. As there continue to be more and more drones in the sky, everyone must take the safety of their aircraft into their hands. So next, I will explain to you about my objective. So there are 3 objectives. First, to develop a drone with parachute system for safely landing in case of an accident, attack or loss of control. So next, to design, fabricated and develop the feedback control system of a drone using Arduino and PID controller. And last, last objective is to test the system response of PID accuracy when the drone landing with parachute. Next, I will explain to you about literature review, which is chapter 2. So this journal is quite similar with my project. So the journal title is Design a Fully Automatic Drone Parachute System with Temperature Compensation Mechanism for Civilian and Military Application. So this journal is created by Al-Madani and published in 2018. So a system for unlocking the parachute ejection mechanism was created, which deploys the spring holding rope. So the system is particularly lightweight and has a small additional space since it no longer requires a heavy servo motor. So the system is managed by the Arduino microcontroller, which processes the sensor data and controls the outputs. So the result. So the first picture is their drone, which is their crate that by themselves, and next picture is the electronic board diagram. So next I will explain about the last chapter of my presentation, which is methodology. So first I will show you the flowchart of my process. So first, start and then identify problem statement and create literature review, which is make any research. And then we will go to hardware development. So hardware development spread by two, which is mechanical development and sensor and software development. So after we do sensor and software development, we will test the system. If the system give a bad result, so we will do again the system testing. So if the system give a good result, and then we will go through to hardware compilation. And then after we do hardware compilation, we will test the drone and get the experimental result, record and analysis. So after we do the experimental, so we will create a project report, and then the end. So next, I will explain about development of software system. So first software system, I will use MATLAB or simulating software. So MATLAB is a programming platform designed specially for engineers and scientists to analyze and design systems and products that transform our work. So MATLAB is used to analyze data, develop algorithms, and create models and applications. So MATLAB is a proprietary multi-paradigm programming language and numeric computing environment developed by MathWorks. MATLAB allow metric manipulations, plotting of function and data, implementation of algorithm, creation of user interfaces, and interfacing with programs written in other language. So for the second software system, I will use Arduino IDE. So Arduino Integrated Development Environment is a cross-platform application that is written in functions from C and C++. So it is used to write and upload programs to Arduino compatible boards, but also with the help of third-party cores, the vendor development boards. So Arduino IDE supports the language C and C++ using special rules of code structuring. It also supplies a software library from the writing project, which provides many common input and output procedures. So these two software, MATLAB and Arduino IDE, I will use to test my system. So next, I will explain about my flow chart of software design. First of all, we will start the program, and then we will turn off power. Then we calibrate the GPS. So and then we will turn on power back, and there are three testing we will do. First, we will do free fall check, and then check GPS location, and last, man power voltage. So for free fall check, when the free fall achieved, so the power will be turned off and the parachute will be deployed. Next, for the GPS location, when the drone is fly out of the GPS location, so the power will be turned off and deploy the parachute. And last, for manpower voltage, so when the system detect the voltage is reduced, so the power will be turned off and deploy the parachute. Last but not least, I will explain about development of hardware component of my project. So this recovery system is controlled independently of the drone flight computer through the use of an Arduino Nano microcontroller powered by separate 7.4-volt lithium polymer battery to ensure proper operation of recovery system in the event of depleted main battery. So we use a few components in this recovery system. First of all, we use Arduino Nano as a microcontroller of this recovery system. Next, we use accelerometer. So the goal of accelerometer is to monitor the UAV for detecting free fall. These accelerometer values need to be set to detect free fall. So in this case, when operator loses control of aircraft, where many UAV cannot recover from free fall acceleration, the recovery system will deploy a parachute and cuts power to the main control via the relay. So the accelerometer will detect free fall when the drone is experiencing zero acceleration in X Y, and Z direction. So next, we use voltage sensor. Voltage sensor used to determine, monitor, and measure supply of voltage. When the voltage of main battery is inadequate or not enough, the voltage sensor will detect, and recovery system will cut off power to the drone via the relay and deploy parachute for a safe landing. So next, we use servo motor. Servo motor is used to deploy the parachute when get signal from the microcontroller, which is Arduino Nano. Next, relay. Relay is used to cut the power to the drone's motor when get signals from Arduino Nano. And last but not least, GPS module. So we use GPS module is used to determine the position of drone. If the drone exceeds the predetermined range, the recovery system will take over and cut power to main system. Once it's cut power, the recovery system will deploy parachute and land safely.